promised you I would podcast the solution to one of the free response problems for tomorrow. It's going to be Kinetics problem. I did hand this out to you guys in class today. I know that I said it was going to be free response problem number 2. It's actually going to be problem number 3 tomorrow. Not a big deal. You can do it second if you would like. Here we go. It says answer the following question about chemical kinetics. I see my reaction. I know initially if I'm talking about kinetics, talking about rate, I know that when I'm talking about the rate of reaction, I have my energy diagram and time here. That's what a catalyst does. Okay, here we go. It says that iodide ion is oxidized to the hypoiodide ion by hypochlorite in basic solution according to the equation above. There it is. And they give me these 3 initial rate experiments were conducted. I see I have experiment 1, 2, and 3. Now when I'm doing these problems, I want to look for places where one is held constant and the other changes. So initially in 1 and 2, Cl is held constant and I changes. And in 1 and 3, I is held constant and Cl changes. That's the first thing I want to look at with these kind of problems. It says determine the order of the reaction with respect to these 2 things listed here. Show my work. So what I want to do is first know that the rate order of a reaction is going to be rate equals K multiplied by some factor. We'll call that X for each reactant, and CLO, call that Y. So what I'm going to do is I'm going to take 2 over 1 first, because that is where CLO is held constant. So in 2 over 1, I'm going to plug everything in. So my rate is right here, 0.476 equals K multiplied by what I is, 0.052 raised to the X power multiplied by what Y is, 0.015 raised to the Y power, all over 0.156, which is equal to K, this is for 1, multiplied by concentration of 0.017 raised to the X power multiplied by 0.015 raised to the Y power. The K's cancel. Okay, these all cancel. We are left now with 3 over 1 is equal to 3 over 1 raised to the X power. So the order is 1 for I. So that is 1. For CLO, we're going to do it similarly, but we're going to use 3 and 1. So in 3, 0.596 is equal to K multiplied by, I don't want that, multiplied by, I don't want you, K multiplied by 0.016 raised to the X power multiplied by 0.061 to the Y power over, these are coming from here, sorry I don't have much room here, over 0.156, which is equal to K raised to 0.017. Now notice this is 017 and this is 016. It's pretty much the same thing. They're going to cancel out. Actually, this is to the 1, so we know that. Multiplied by 0.156. So I'm going to do this out. The K's are going to cancel. This is going to cancel. And I'm going to get, again, this is going to be 4 over 1. It's going to be equal to 4 to the Y power. So Y is going to be equal to 1. Now, if this was 16, that Y would be 2. If this was 1, Y would be 0. It all works out in the end. So it's first order for each. The rate law expression is simply rate is equal to K multiplied by I minus to the first multiplied by CLO minus to the first. All we did was plug in the orders into the rate law expression. Calculate the value of K and specify the units. So we can just pick one run, any one, why don't we do 1, and we can just plug it in to the rate law expression here. So for 1, rate 0.0156. 0.156 is equal to K. K multiplied by 0.017 raised to the first power multiplied by 0.015 raised to the first power. So let's do that out together. Clear. 0.017 times 0.015 equals 2.55 times E, so 0.0156 divided by 2.55 negative 4 equals, K is 61. It's actually, 61. And you can say 61.2 if you like. And now we got to find the units on K. So I'm going to go over here and do the units on K. So we know that rate is given in moles per liter per second. Okay, that is right here. And these are all moles per liter. So it's equal to K times moles per liter to the first over moles per liter to the first. So moles per liter second equals K times moles squared liters squared. Away. Oh. Okay, not having a good day today. So you rearrange this and you get moles liters squared over liters second moles squared. This goes, this goes, this goes, this goes, and it ends up being liters over mole seconds. What is the oxidation number of chlorine before and chlorine after? So it goes from Cl minus, Cl minus. So in this case, x minus 2 equals minus 1. So in this case, x must be plus 1. And in this case, it's minus 1. So it goes from plus 1 to minus 1. It's reduced. So it's the oxidizing agent. See you guys later. Take care.